All right. Good morning, everyone. My name's Boyd Anderson. I'm here to present our work, Ruggedizing CS1 Robotics, Tools and Approaches for Online Teaching. This is a joint work with Martin Hens and Hao-Wei T, who are both here today. We're all from the National University of Singapore, and we would like to talk to you about our experiences and technology for teaching CS1 robotics online. So before we get started, I need to give you a bit of introduction about the system that we currently have. In our CS1 course, we use an open source student-built browser-based IDE. It's called the Source Academy. And all of our student programs are written within a language called Source, which is a series of sub-languages of JavaScript. If you are interested in this Source Academy project, we have a few talks, any of the talks from the National University of Singapore today here at Splash E. So come and have a watch of some of those. Now, for our course, CS1 is a crucial component. Our CS1 course starts as a purely functional programming course. And the introduction of robotics happens at the same time. It coincides with the reintroduction of mutable state and assignment into our course. So the robots give us an opportunity to explore that. It also provides the students an opportunity to engage in group work, especially important when we're all doing online teaching, and also to see how their programs interact with and actuate the real world. And obviously, it is also quite fun. Our goal with our system is to basically have no impediments, that is technical or otherwise, to the students being able to apply their programming knowledge that they have gained thus far in the module, in the course, to control their robot. And to do so within this browser-based IDE. We don't want them to have to learn, say, Secure Shell or SFTP to transfer programs or anything to the robot. We are trying to remove all those sort of impediments so they can just concentrate on the learning. However, our previous system for robotics in the module, that is up until 2019, had quite a few shortcomings and limitations that got in the way of this goal. So I'm going to hand over to Hao-Wei to talk about our new system and our old system.
Hey, is my slides on?
Yep.
All right, thanks.
Oh, so we can see your presenter view. Sorry.
Oh, let me try and fix that. Okay, is it right now?
Looks good.
All right, thank you. Our old system was basically Node.js with a custom library running on EV3Dev, right? And EV3Dev is a Debian distribution for the Lego Mindstorms EV3. So it's a very simple.
How-Wei, your presenter view came back on now.
Oh,
I think
that's odd.
Now it's gone. Yeah. Good.
All right, I'm just going to hide it. Okay. Yeah. So it was a simple solution. Built mainly using off-the-shelf components, right? And the benefit of it was that it was basically, it was simple to create and required little maintenance, but it provided a rather poor development experience for our students. So if students wrote their programs on the computer, they, either in our web environment, the Source Academy, or in some other editor, they had to then, manually transfer the programs over SFTP to the robot, right? And yeah, alternatively, they could SSH directly to the robot and then write the programs using a NanoVim or some other command line editor. And neither of these were, particularly convenient or comfortable solutions, especially for students who are new to computing. And these form the majority of students in our CS1 course. So then after getting the programs onto the EV3, they had to execute it over the shell, right, over SSH. And, after executing, entering in the command to run the program, they would have to wait for about 10 seconds for Node.js to actually initialize before the program actually started running, right? And because robotics inherently involves a lot of trial and error, right? Especially when optimizing threshold values for sensor readings and things like that. This inherently just made the whole development experience quite frustrating. So before the pandemic, we used to hold sumo bot competitions every year, and a lot of time was wasted during the competition, just waiting for these Node.js to initialize and programs to start up. So other than the poor edit run cycle, right, there were other issues as well, right? Because Node.js, or rather V8, which is the JavaScript engine that is underlying Node.js, dropped support for our particular hardware platform, drop support for the hardware platform that the EV3 is built on. We were stuck on a rather old version of Node.js that did not support the particular, some of the JavaScript features that we used in source. And so this meant that when writing their robot programs, students had to essentially, switch language dialects, right, on top of all the other frustrations that they already had. And the fact that the whole experience took place outside of the Source Academy also sort of broke some of the immersion that we had hoped to achieve in the course. Students also had to figure out how to use SSH and SFTP. And while these were things that they would eventually have had to learn, the CS1 course we felt was not the best time for that. And this whole setup would have been quite troublesome to use during the pandemic when students could not meet in person to work on their programs together. Well, it would have been fine, right? It would have worked. The person who physically had the robot would have to be the one to sort of, transfer the programs onto the robot each time, and then, enter in the command to run the program every time they had a minor modification and things like that. And it would have been quite troublesome. Either that, or they would have had to sort of, figure out a way to remotely SSH into the system. So either way, it's not a great setup. So now that we've seen the issues with the old setup, which we could sum up as basically poor performance as well as inconvenience, let's look at the new platform. So the first component here is the Source Virtual Machine Language, which is a VM language that was designed as a natural compilation target for Source. So that means that Source statements and semantics translate easily into VM instructions, and the types of values in the VM also correspond exactly to the types in Source. The compiler we also wrote in TypeScript, and this is so that it could be integrated into the Source Academy easily, which is again a web environment. The VM language also includes facilities for us to expose platform-specific functionality to our Source programs. The next component is Sinter, which is our VM implementation. And we wrote it in standard portable C11 and designed it to be run on embedded platforms. So that means that we avoided floating point operations where possible, and also we avoided using dynamic memory allocation at all. And so these two components allow us to run our Source programs on embedded devices like the EV3, but we still need a way to get our programs from the our Source Academy onto the EV3 itself. And so this is where Sling comes in. The name is quite literal. It's a sling that sort of slings programs from our web environment to the our devices like the EV3. So Sling is a simple protocol based on MQTT, which is a lightweight publish subscribe protocol commonly used in IoT devices. In a nutshell, the web frontend sort of sends compiled programs via the MQTT broker to the robot, which executes the programs and then sends the output back to the web frontend. So by MQTT's nature as a publish subscribe protocol, we sort of get the ability for multiple users to connect to the same device at the same time for free. And status and output messages are broadcast to all of the connected front ends, so students can connect to the same robot at the same time. So with these three components, SVML, Sinter, and Sling, we now have our new setup. So this is how it looks like. Students first have to do a one-time setup by registering the robot with our web environment. And then after that, they can just connect to the robot via this panel on the right. And then after that, they can just develop their programs in the environment that they are used to, and then run the programs by clicking the same run button that they're used to. Right? Compilation is virtually instant, and the VM initialization is also instant by virtue of it being written in pure C. So no more manual file transfers or waiting 10 seconds for programs to start. And as a bonus, students also get the completion features of our online environment. So during the pandemic, our students could work together by just connecting to the same robot, and the student who had the robot simply had to connect it to the internet and maybe point a camera at it. and then they could collaborate over a video call. They could also use the collaborative editing feature, which is this session button up here. And it basically works like a Google Docs, except for this code editor over here. And they could then work on their program together live. Now I'll hand the time back over to Boyd, who will continue on to talk about the experience we had designing these assignments in a pandemic and the experience our students had working on them. Thank you.
Thanks, Howie. So we were very worried that we would lose our robotics component, that it was in danger during the switch to online teaching. And we still wanted to have the sort of the standard line follower and obstacle avoidance puzzles that are often in CS1 robotics courses, so that we can encourage students to explore the use of mutable state and assignment. However, we had to try and do this in a take-home manner. So our approach was to design puzzle posters and print these out, and big A0 ones, and one student would come and collect. And our module, however, has about 600 students and about 90 lab groups. And so as you can see from this trolley here, this was a lot that we printed, and the logistics was quite an operation to hand these out. So to summarize, we were able to have face-to-face sessions and online sessions. You can see on the left here, the face-to-face session, everyone is still socially distanced because they're still using their laptops to program it. They can do so in the same room. And here we're seeing an online session where one student points the camera at a robot, and all the students collaborate in a Zoom session. So in summary, our VM-based approach allows us to remove a lot of the impediments to programming the robots and improving that edit run cycle that Hallway talked about. Students can program the robots directly in their browsers, and we didn't have to sacrifice this robotics component. Indeed, during the year 2020, the feedback that the robotics component got in the module, in the course, remained positive. And I'll end this talk with a bit of an advertisement and a bit of a call. Our tools are open source, licensed under the Apache license, and they're available on GitHub for you to use. And Sinter has been designed, it's written to be compilable using a C11 compiler. So any embedded system that you have one for that, you can use, and you don't need to use Lego Mindstorms for that. So here is our links here. Thank you very much. Sorry, we went a little bit over time. Any questions?
All right. Thank you. Are there questions in the room? We don't have questions in the room. Are there questions on Zoom? All right, I have a question for you. So this is Charlie Kurtzinger at Grinnell College. I'm curious how much of this is specific to robotics and how much would be adaptable for other kinds of embedded development. Do you think this would work for an upper level class where someone is programming microcontrollers and they're not just using it as a platform to learn in CS1, but later on in their curriculum?
Well, we sweep a lot of the details under the rug. So I think for people who are learning to write low-level programs or program embedded systems, this system is probably not as appropriate for that. But Hallway, what do you think on that?
Yeah, I kind of agree, because we really don't expose, like when you are programming microcontrollers or learning to program microcontrollers, you probably want to learn about the lower level details like poking registers and things, which all of these we sort of hide, because our main idea is just to expose the motor sensors and things like that. Yeah. But again, because of the way Sinter is written, you could definitely write expose registers directly to the source language, right? And then that would possibly work as well. But I feel like, I don't know, part of learning microcontrollers is also learning to deal with C and assembly.
The pain of microcontrollers. Yeah.
Fair point. Thank you. And thank you for staying up late with us. I've lost track of the time difference, but I know it's a stretch for you folks. So thank you very much.
Our pleasure.
Thank you.
Thank you.